I'm a mathematician and I work as a core developer at Wolfram Research, and we are developing the Wolfram Mathematica, Wolfram Alpha, and other systems. Also, I am an AI educator, and I train like different students to get the insights about AI, different models, and so on. And this year, I was the team leader and main trainer of the Armenian team for the International Olympiad in AI. And because of that, I am quite I'm quite good with artificial intelligence, its history and evaluation. So let's start today's talk. All right. So the point is that AI didn't start with ChatGPT. We all know that ChatGPT came a couple of years ago, and most of the people they think that the ChatGPT was the first example of AI, but in fact it's not. So AI is a 70-year story of humanity's ambition to recreate intelligence. And this is a very interesting topic. So let's dive into that today. And start with the overview of today's lesson. So I will give the definition of artificial intelligence. I will speak a bit about the history of artificial intelligence. I will show the difference between AI, machine learning, and deep learning. We will a bit talk about types of AI, narrow AI, general AI, superintelligence. And of course, we'll talk a bit how AI is created, because this is a very important part. And at the end, I will give some specific AI algorithms that are working under AI tools that we use for our everyday life. So let's start with a definition. What is AI? So AI is a rapidly developing subfield of computer science that involves the development and study of algorithms, models, and systems that can perform tasks that typically require human intelligence. So this is the definition of AI. And here a couple of key points are presented, like subfield of computer science. This is about study of algorithms, models, and systems. And the main key point here is that AI can perform tasks that usually humans do. And let's a bit talk about the human intelligence. What is the human intelligence? This is the intellectual ability to think, understand, reason, remember, create, learn from experience, make decisions, problem-solving skills, and so on. So there is no like one strict definition of human intelligence, but all these points are about the human intelligence and about the intellectual abilities of a human. And the point is that if we are trying to take these abilities and create them artificially, then we are getting an artificial intelligence. And now let's go back to the definition of AI and see here that AI can perform tasks that typically require human intelligence. So ideally, we want AI to think, reason, create, solve some problems, and so on, exactly like we do. And even more ideally, in a more nicer way, we want AI to be better than human intelligence. So so this is just showing that if we are taking the intelligence, the human intelligence, and trying to mimic that artificially, we are getting the artificial intelligence. A very representative example of AI is, of course, the ChatGPT, which is available at chatgpt.com. And I am quite sure that everyone of today's attendees uses the ChatGPT. And the point is that ChatGPT, in fact, is a conversational AI that can understand the text that we are typing. It generates some answer and, of course, reasons about the output using our humans like natural language. And in fact, the ChatGPT was it wasn't the start of AI revolution, but this is a very, very representative example because ChatGPT showed the world how AI can sound like when it finally speaks our language. Like not just giving some output as a code, for example, or numbers, but directly it mimics the natural language and speaks with us. And this is a very, say, it's a revolutionary technology, of course, and it is based on a GPT and neural nets, and we will talk about them at the end of this presentation. So just a couple of more points to say about ChatGPT. Here is an example of a small chat where we asked to write a code in Python language for factorial calculation, which is a mathematical function. And of course, ChatGPT was able to write that code, which is of course working. It is nice code and so on. And of course, it tried to explain what this code is doing. So not only generating the code, but also some reasoning under that, why this code is written like this. And of course, we see this type of stuff every day, working with ChatGPT and other big models. And of course, there are other different examples of AI, and we all know them. As an example, there are AI-powered robots. There are vehicles, autonomous vehicles that can drive the cars, and not only the cars. There are AR, VR devices, which stand for augmented reality or virtual reality, and these are all based on different AI algorithms. Voice assistants like Alexa, Siri, and others, and of course Google, can interpret the natural language that we speak with it, and so on. YouTube and all other services, they're using these voice assistants. Yeah, of course, recommendation systems. So while scrolling the feed in, say, Facebook, Twitter, Instagram, and so on, we see different information that is recommended to us by AI systems. And they are, in fact, doing quite nice these days because they are giving recommendations on topics that are interesting for us. And so on, of course, there are different other examples of AI. But the point is, the general point is that AI can solve a lot of problems right now. So the models of AI that we have in 2025 can solve a lot of problems. They can simplify our lives. They can make the work process faster, and so on. Yeah, probably attendees know about services like Copilot, Gemini, and so on. So these are all AI systems. Yeah, one nice example of AI system is the Midjourney, which is a generative AI. And this Midjourney was and is generating pictures or pictures from the description. So we are giving a text description, like I need panda, which is a scientist, and it's like mixing some chemicals and so on. And AI is generating a picture of that. The point is that these AI systems that are generating pictures, they are doing rather nice these days also. Another example of generative AI, Adobe Firefly, which has a lot of AI tools like use a brush to remove objects or paint in new ones, generate images from the text, recolor something, and so on. And now let's go back and talk about the history of AI. So what do you think when the term AI appeared, or when the AI systems were like theoretically described? The point is that Alan Turing invented Turing's test in 1950. And this test is a method to determine if a machine has human intelligence or not. So imagine that we are asking some questions to computer, and there are like two rooms. In one room, a human is responding to this question, and in the second one, computer is responding. And we don't know the responses from which room. And if we think that the human is the responder, but in fact is the computer, then this computer has an AI. This is simplified the Turing test. The point is that right now, as an example, ChatGPT is writing responses like a human. So the services like ChatGPT can pass this Turing test. And this this was about 1950. And after that, in 1956, the Dartmouth Conference introduced the term artificial intelligence. And the founding fathers of AI are presented on this slide: John McCarthy, Marvin Minsky, and others. So they introduced this term, artificial intelligence, and we can see the timeline of the development of artificial intelligence. So we see that here in 1950, the Turing test, in 56, the Dartmouth conference, then in 80s, we had some expert systems. In 1997, the Deep Blue beats Kasparov in checkmate. And in 2012, the deep learning revolutionized the field of artificial intelligence, and so on. And now we are living in the era of large language models, agentic systems, and so on. So this is a big path for 70, 75 years. And a lot of work was done during this period, and a lot of problems arose during this problem, and so on. Okay, just slightly giving all this stuff. So in fact, in 60s, 70s, 80s, a lot of work was being done for creating AIs. But the point was that we were lacking computational power, computers, and so on. And because of that, the systems were really simple. They are mostly logic-based systems, like some trees of decisions, and so on. And in 1990s, machine learning started to show some nice results because our computational power increased, and some systems arose then, like the handwritten digit recognition system by Jan LeCun, and so on. And starting from 2010s, the deep learning started to show very nice results. And all this was because of the GPUs and the different languages of programming that can make some calculations on the GPUs. And the first systems were about the image recognition, speech recognition, then computer vision, image segmentations, and a lot of other stuff. And then at the end of 2010s, the large language models based on, say, GPT architecture showed their results. Then we went to the generative AI, and now we're trying to make some artificial general intelligence. So this is the, say, detailed timeline of the development of AI. But also, the point is that we had a couple of AI winters. So what is the AI winter? This is a period of significantly reduced funding, interest, and research. First of all, in artificial intelligence, which is usually followed by a circle of hype and over-optimistic promises. So what's the point? Say the artificial intelligence term is available for 70 years, but scientists were trying to do something with that to create these AI systems, but they are facing the problem of low computational power. And then the first AI winter, which is like conditionally written here as 1973. Then we have some first expert systems available in 80s. Then we had the second AI winter, say no funding, no interest, but some research in this area. And then say the machine learning algorithms in 90s, then probably some third AI winter, small winter, and then deep learning revolution. Okay, so that was about the history of AI. And now let's move to the next topic, which is about difference of machine learning, deep learning, and AI in general. And here I have the same definition of AI written on this slide. And also we see a small plot about artificial intelligence, which is any program, any algorithm that can perform tasks like a human is artificial intelligence. And a subfield of that is called machine learning. And machine learning also has a lot of subfields, and one of them is called deep learning. So let's talk about them. Machine learning. It's a subfield of artificial intelligence, and it enables a computer to learn from data and improve its performance on a specific task. But the interesting point here is that machine learning works without being explicitly programmed. So of course we have some code lying under different algorithms, but we are not explicitly programming what should be the output of the model. And how this ML works, we need the data to learn from it. We need to pre-process this data somehow. We need make it better, deal with some outliers and so on. Then we have to pick the model, the machine learning model that we are going to train on this data. And we can solve different problems like regression problem, classification problem. We can use different algorithms like DT, which stands for decision tree, or KNN, which stands for K nearest neighbors, and so on. So we need the data, we need to pre-process this data, then we need to pick the model. We need to train this model on the data, get some working algorithm, and after that we have to evaluate the work of this algorithm, how well it works. Does it meet our expectation or not? And if everything is okay, we can deploy it and monitor how this model works. And if we see that the model is not doing well, we should repeat the circle, collect maybe another data, reprocess it maybe in a different way, make this training process, make some evaluation steps, and they deploy it and monitor the results. This is how ML works. And here I have a very, very simple decision tree, which is just giving if the passenger on the Titanic will survive or not. And this is a decision tree, which is a machine learning algorithm made on this data. And we see that there are some, say, rules, like what is the gender, what is the age, and so on. And we get the solution. The model gives the solution based on different, say, features, gender, age, and so on. Okay, all right. So what are the real world ML applications? ML is applied in e-commerce and marketing, as an example, recommendation engines. Then in healthcare, like we can analyze medical images really quickly using ML algorithms. In finance, like detecting some transactions or for the forecast of stock prices or something else. Natural language processing, like building chatbots, or even simpler, detecting the spam emails. And of course, more. So there are, for say 30 years of machine learning development, scientists and engineers made a lot of models with a lot of applications. Sometimes ML is doing nice, sometimes it's not doing that nice, and so on. But generally, ML models are quite simple and understandable. So we can understand what the model is doing with the data. And about the, okay, all right. So this is a small plot how the model training is done. So we're training with some data, getting the model and making some predictions. And what about deep learning? What's the difference between machine learning and deep learning? So first of all, deep learning is a subfield of machine learning. And the point is that deep learning uses artificial neural networks to solve the problem. And in some sense, it's trying to mimic the human brain, how the human brain works. And the nice point of deep learning is that for a lot of problems, real world problems, we are just collecting the data, giving it to the neural network and getting the output. While for machine learning algorithms that are simpler than networks, we have to do some work with the data first. We have to get some interesting features, extract this process is called feature extraction, and so on. For deep learning models, we are collecting the data and giving to the network. And mostly it is okay. Mostly that works. All right. So what is a neural network? So a neural network has a lot of neurons inside, and we see on this plot are like input layer, hidden layers, and output layer, and all these layers have some neurons, like the human's brain. And these neurons are connected to each other. So they are, say, transferring some information, starting from the input layer to the output layer. And the data flows through these layers. Each layer tries to learn something, some patterns, and finally, we are getting some out. So this is the simplified description of the neural network. And as I said before, it's trying to work like the human's brain. But we don't understand like really how our brain works. And we have some model which is based on these neurons, and we call it neural networks or deep neural networks. And what are the real world applications of deep learning? First of all, that's computer vision, natural language processing, generative AI, like generating text, generating pictures, generating a lot of stuff, generating some information, so on, and of course, some others. The point is that the model of deep networks is available for dozens of years. But the point is that first, in 2012, a network called AlexNet dominated in the ImageNet competition and showed that the deep learning has a much bigger potential than the machine learning algorithms. And it was like only 13 years old ago. Yeah, so if we will go back to the timeline of the artificial intelligence development, here we see that everything started with a Turing test, then the Dartmouth conference, then some work in 80s, 90s, and then we got this AlexNet, which was the first example of applying, say, deep learning, the deep network in a competition and getting a very, very nice results. And after that, after 2012, a lot of new models and a lot of architectures were researched, developed, and applied to different problems. And we right now have very nice models that are called large language models or LLMs. All right, so a couple of examples of applications. One of the basic examples is the speech-to-text technology. While I'm speaking with my phone, say Siri, I'm speaking with Siri, and Siri is transforming my speech to some text and working with it. Or the Boston Dynamics robots that are using AI to solve different tasks, problems. And of course, in fact, right now, in 2025, AI is applied in probably almost any field of our life. So it can be healthcare, finance, social media, education, of course, gaming, robotics, agriculture, e-commerce, and so on. So everywhere, AI is everywhere. And now let's talk a bit about the following. What is the aim of AI models? So in fact, we are trying to build something that can solve problems like us. All right. But can we describe these AI models mathematically? And the answer is yes. So mathematically, AI model is trying to map data into labels. And if we will try to write a formula, then the formula of AI model will be like this. So here the y is the label, and f is some function of x. X here is data. So we are trying to get this function. When we are training our model, we are trying to get this function. But the point is that this is not so simple. So even for a very simple network, neural network, we cannot write this function explicitly. But this is our aim mathematically, to get this functional connection between the data, which is x here, and with the labels, which is y. All right. And what about the aim of AI models from the technical point of view? And technically, AI models, they try to learn some general patterns from the data, like humans do. So when we see something new for us, we are trying to understand what it is. AI models are trying to do that. They're trying to learn from the data that we provide and learn something which can be useful for our problem. Yeah, so this is on this demonstration. In fact, each next layer is trying to learn something more complex from the data. Okay, so this was just a, say, philosophical slide about the aim of AI models. And now let's talk a bit about the types of AI. So in fact, there are three types of AI. First is the narrow AI, which solves a specific, very well-defined task. Like we're chatting with ChatGPT, we are writing some question, what's the weather in Boston today? And ChatGPT is trying to generate the output. Or I have this picture and I want to recolor that. Okay, AI can do that. And this is a narrow AI. And narrow AI is mostly about making our lives simpler and about helping us to solve our problems, specific problems. The next type is called general AI, AGI, artificial general intelligence. And this type of AIs will have a human-like intelligence and will solve the problems of the same complexity that humans solve and be very universal. And the last type of AI is called superintelligence. And we hope that superintelligence will solve problems that are far beyond human level intelligence. So right now, all the AIs that we use in our life, they are narrow AIs. And even like ChatGPT, Gemini, and others, they are narrow AIs. And we are waiting for the general artificial intelligence. And if we will try to plot these AIs, so narrow AI, it's a robot, say. It's solving some very specific task. It's doing really nice, but only on this specific task. And general AI will be like human. It will be strong enough to solve really complex problems. And the super intelligent AI is something that we don't really understand what it will be. All right. And now let's move to the following topic, which is about creating AI. So how to create AI? All right, I am a mathematician, I am a researcher, and I want to create an AI. What should I do? And here, first of all, I would like to say that there are AI users and AI developers. So we all use AI tools every day, but only a few of us develop them. And the point is that developing AI is a super complex problem. And what do we need to develop AI? First of all, of course, we'll need to write some code. Then we'll need some GPUs, or graphic processing units, to evaluate this code, to train some models. And finally, combining these two together, we will get an AI, which is in fact nothing else than a code working on some device. But what we really need to develop AI? First of all, we have to formalize the problem that we are trying to solve with AI. Then we, of course, need AI researchers for that. And we need a really nice specialist to create something really new. It's a very hard problem. Then we need AI engineers to understand the architecture of AI that we need here. Of course, we need some coders to write the code, very nice code. But aside from these, we need also huge computational resources to train our model. And also we need a lot of data. So a lot of data to train some AI model. And just to give an idea of what we need for training a large language model, like a GPT, say right now ChatGPT is using the GPT-5, and to train such a model, we need a petabytes of data. And we'll give this data to the model, and the model will try to learn something from that. And we see that, say, the GPT-5 or GPT-4, they are doing great. They are learning a lot from this data. Also, technically, to train an LLM, we need thousands of GPUs. And the point is that these GPUs are very expensive. So it can be like 10K for one GPU. And we need, say, 5,000 of them or 20,000 of them. Or in fact, for GPT-5, it is estimated that we need 25,000 GPUs for training this model. And also the point is that we have to train the model for months. So say for GPT-5, it is from 90 to 120 days of training, continuous training on the GPUs, which are very expensive. And of course, training an LLM is not cheap. And say to get the same level of performance like the modern LLMs are doing, we need millions of dollars. So the order is, say, $100 million to train this model. So this is not very cheap. In fact, it's very expensive. And you need to do a lot of work to train your language model. But the point is that it will help you a lot in your life. It will write a code for you. It will generate some summaries. It will solve a lot of problems and so on. So probably it's nice to have these LLMs. And now after all this, let's go to the algorithms of AI. So as I said before, artificial intelligence is a big field. And it has a subfield called machine learning. And what are the key topics of machine learning? And in fact, the classical machine learning has a supervised learning algorithms or unsupervised learning algorithms. And the supervised learning is when you give the algorithm the data and also you give some labels for this data. And in that case, we can solve two problems. The first one is called classification problem, and the second one is called regression problem. So say we have a lot of pictures, say 100,000 pictures. And on these pictures, we can have a cat or a dog. And we want to train a model which is predicting if on the picture cat is pictured or a dog. So this is a classification problem. And the model outputs like this is a cat, or this is a dog, or this is a boat, or this is a car, or something like that. Regression problem is when we're trying to predict some number from our data. Like we have a very big data set of houses in some city. And in this data set, we had a lot of information, say the number of rooms, the other parameters of the house, and we need to predict the price of this house. So the prediction answer will be like from, say, $50,000 to $2 million. And this is a regression task. This classification regression are done using a supervised learning algorithms. Aside from that, we have unsupervised learning algorithms that are about clustering, dimension reduction, associations, and so on. So what is clustering? Say we have a lot of data and we want to get some common patterns between these data points. This is a clustering task. So say we have a lot of pictures, have handwritten digits, and we are trying to understand which digits we have there. So obviously all the pictures of zeros will be in one cluster, the ones will be another one, nines will be another one, and so on. And this is unsupervised machine learning problem, as we just give the algorithm, we give the data to the algorithm and nothing more. And algorithm is trying to learn something similar into different clusters of the data. Dimensionality reduction is another nice application of ML, and it is about making the data smaller, but trying to keep all the information that is needed. So say I have a very big data set, which is a very big matrix, and I need to make it smaller, but I want to keep the information that is written there. And this can be done using different dimensionality reduction algorithms. And associations are about identifying some sequences in the data, like here is an example, find what clothes I often wear together. This is another task that can be easily done using machine learning algorithms. And aside from supervised and unsupervised machine learning models, we have also reinforcement learning algorithms that are some machine learning models are trying to learn something from the data, but the point is that we are not giving labels for this data, and the model is trying something, and then it is getting a reward or it's not getting a reward. So say if it's doing something correctly, then it's getting a reward. If it's not doing it correctly, then it's not getting the reward. And the idea here is that the model will try to maximize this reward and learn something from the data. And reinforcement learning is used in like different, say, gaming applications and so on. All right, so this was a simple overview about ML models. And what about DL topics? So DL, or the deep learning, is a subfield of machine learning, and it tries to solve the problem with artificial neural networks. And it can solve different problems like the natural language processing, or some robotics problems, or computer vision problems, or expert systems, and so on. As an example, computer vision problems can be like the Face ID that we have in our phones. This is a computer vision problem. Understand if I am using my phone or something else is trying to unlock it. And NLP is what ChatGPT is doing with us when we're writing something, getting the output. So this is an NLP task, and so on. And at the end of my presentation, I am presenting some specific algorithms that you can deep dive and try to understand or learn how they are working. So first group that I brought here is the linear regression, logistic regression, and linear classifiers. And such algorithms are available in many Python libraries about machine learning. Then I have presented the k-nearest neighbors, decision trees, support vector machines, and these are about solving the different problems, but solving in a very understandable way. Also, we have some clustering algorithms that are k-means, k-means++, dbscan, and principal component analysis for dimensionality reduction, and so on. These are just some specific algorithms to have here in this presentation. Also, for reinforcement learning, we have some algorithms like Monte Carlo tree search or Markov decision processes or others. And now let's show some deep learning algorithms And first, I want to present the convolutional neural networks that were developed to solve computer vision problems. And CNNs, or convolutional neural networks, they made the revolution in AI. And the AlexNet, which is a neural net from 2012, is a convolutional neural network. So the CNNs showcase the potential of deep learning. After CNNs, another type of network was developed, and this is the recurrent neural network. So the recurrent neural network is completely different from the CNNs, and it's trying to say use the information as much as it is possible recurrently, and recurrent neural networks started to perform really nice on text on natural language processing problems. Another type is called generative adversarial networks that can be used to generate some pictures as an example or something else. And this is other. This is also different from the RNNs or CNNs. And finally, there are transformers, which introduced a very interesting and useful, say, approach. This approach is called attention mechanism for self-attention, and transformers were presented in 2017. And all the current LLMs like ChatGPT, Cloud, Gemini, and so on, they are based on these transformer networks. And at the end, I wrote the generative pre-trained transformer, which is nothing else than the GPT. And ChatGPT is using this architecture. I think this is all for today, and thank you for your attention. And now I'm ready to answer some questions.
All right, thank you so much, Tigran. We have questions coming in right now. Let's get started with Ismail.
Yeah, thank you, sir. Yeah, good morning, sir.
Hello.
Good morning.
Yeah, good morning, the presenter. Good morning, everyone. My question is this, sir. Based on the historical trend in the artificial intelligence development, what prediction can be made about the future trajectory of artificial intelligence technology, even by considering factors such as regulation, public perception, and technological advancement?
Oh, that's a very, very nice question. So in fact, I don't think that we know what will be, say, in 10 years or even in 5 years, because the level of AIs that we have right now is so advanced that we couldn't imagine about that like a couple of years ago. So my answer is this: I don't know. Let's see what we will have in 5 years, say 10 years, and what will be the impact of AI technologies on our lives.
All right, now we go to CC Jules for the next question.
Thank you very much. Very happy. So I have a bunch of questions, which is first, how ChatGPT technically works with RAG and LLM, large language model. RAG is a retrieval augmented generation. Question 2, could you please explain the transformer process? Question 4, I think all the question is already in the chat box. Yeah, to have time and check them. What role does play dependency file back and front end when deploying a AI model? And which programming language is used in AI? And what do NumPy Pandas Hugging Face library bring to AI programming? And last question, what action can be taken to block student or professional who use AI to answer like testing subject and so on? what action we can take, because we need to build their own skills instead to use AI responding to their place during the test and so on. Thank you.
All right, let's start with the ChatGPT. So what ChatGPT does is the following. So ChatGPT is, say, just a website which is trying to get your question and also print the answer to your question. And everything is processed on the GPT-5 technology right now using. The point is that first we're typing something, and this is a ready text. Then this text should be, say, processed and worked out. And to do this, we need a tokenization process. We need, say, some embeddings for this text and so on. And after that, the text can be fed to the GPT-5 or any other large language model. Then the model tries to understand what is your question and generates something as a response using some reasoning techniques and so on. And when this output is generated, the ChatGPT is trying to decode it and give us a text. So in fact, the GPT-5 gets some numbers and works with numbers and outputs numbers. What ChatGPT.com is doing is trying to shift these numbers back to the text and write on our screens. This is about the technology, and any LLM is working like that.
Yeah.
So you have some
interface. Please. I just for the ChatGPT we have the RAG, the retrieval augmented generation, that taking the input from the user and go and search in the database, vectorize the I think the expectation of the user, expected answer for the user, and after it the LLM come to take and display now the response to the user. Right?
No, LLM is taking the, say, vectorized text with numbers and working with these numbers. And as an output is giving another vectors.
Okay.
Then the interface is trying to.
Second question. Yeah, this one is okay for the ChatGPT process. Would you please explain the transformer process?
Yeah, all right. So I will try to explain it simply. So what is a transformer? It is a neural network that is using an attention mechanism. And the point is that when you have an input, say you have a text, and first this text is transformed to some vectors of numbers. And you can try to directly load these numbers to your network and get some output, or you can try to get the important part of this vector. And this is the attention mechanism, in fact, which means that you are trying to get the important part of the text that you are giving to the network. Because the networks are trying to catch the context of the text and some key points of the text, keywords, and so on. And all this is done using this attention mechanism, which is inside the transformers networks. And the point is that the network is also being trained so that it focuses on some parts of text during the training process.
Okay.
And mathematically, it's very hard.
Yeah, I know.
But the idea is like
you get the point. You got the point. It's okay. What role does play the dependency file back and front end when deploying an AI model? This is the third question.
What is the? Can you repeat that? I mean,
what role do play the dependency file back end and front end during AI model deployment?
That's a good question, and I don't think that I can answer that one. Because the point is that I'm developing neural networks from the point of view of an AI researcher. I'm not more about deployment process. So I
Okay.
don't know the
Okay.
technical like details of that.
We can pass to the fifth question. Which programming language we use in AI, and what to do the pandas, NumPy, and Hugging Face library bring to AI programming?
Oh,
No,
so the
NumPy,
base of
pandas,
the
Hugging Face libraries.
okay. So the base of AI is the Python language and all the modifications. And
Okay.
mostly, say, the researchers are using different libraries like TensorFlow, Keras, and the PyTorch, Torch, and so on. And say NumPy is a library for Python, which is about doing a mathematical operation with matrices in the fastest way. Say. Pandas is a library for working with the datasets.
Okay. The last question.
Hugging Face.
It's okay, please. Sir, it's okay. The last question is what action can be taken? This is a very relevant question because we are, as today, student and professional, they tend to use AI or virtual assistant to answer the question they were supposed to answer by themselves. So what action can be taken and stop this kind of cheating the educational core and so on?
Another very nice question. What to do? That's a good question. So first of all, develop systems that can catch the AI generated answers. So develop AI systems that will catch the AI generated something. And this is a very big problem because I am also, say, high school teacher, and I am having this problem all the time. So the students, they are not trying to learn, they are trying to get the answer from the different systems. This can be ChatGPT, this can be like Gemini or something like that. And right now, my understanding is that we don't have anything to fight this AI solved, say, homeworks and so on.
We cannot
Probably
short.
something will be developed in the nearest future because otherwise we'll lose the ability to think.
Yeah. But
Because everything
Mr.
will be done by AIs.
Yeah. But Mr. Tigran,
So this is a very big problem for
I
students.
suggest to maybe wearing testing professional or student for homework or quiz and so on to short the time for the how they call for the test. If in this case they won't have time to search from AI virtual assistant like ChatGPT or Copilot. We just shortly the time of the assessment. This is one of the hypotheses. I mean, I can suggest.
And also there is another approach, like make the learning process insert a gamification to the learning process and try to make it as interesting as it is possible. And then probably students will try to learn and not to cheat using ChatGPT.
Yeah.
The next approach is that you have to do something in the classroom, because if you will give a homework, then the homework will be done using different assistants. So what you learn in the class is what you learned in total. So there are different approaches, but in fact, this is a very big problem, and I see like in reality how this affects the learning process of different students.
Okay. That's
from
good.
my point of view, like AI assistants are nice for me because I have a rather big knowledge, say, in mathematics and so on, and AI assistants are helping me in my work. So I can like spend one day to write some code, but I can spend 5 minutes to explain how this code should be written. The AI system will write it while I will think about some more complex problems.
That's good, Mr. Tigran. That's good. Thank you.
Thank you. Thank you for questions.
Yeah, there was a question that was sent to me from Abdoulaye that, let me go ahead and read it. Does artificial intelligence strengthen human intelligence? So you've just touched on that, but it can weaken it or strengthen it. Can you elaborate on that?
Oh, in which sense? Strengthen or?
Well, like you were saying that it can affect learning. It can weaken the learning if people just use it for this.
Of course.
But are there ways that it can actually strengthen human intelligence? Critical thinking?
Yes, and in general, I think yes, and this is the point. So, say you are learning some new topic, and there is something that you cannot understand, and you are very, very interested in this, but you don't have your teacher right now near you. So you can use AI to get a reasoned answer to your question and understand the topic deeper. And because of that, you can use, I mean, if someone is interested in learning, then AI will help a lot in the learning process. Because AI sometimes is giving like different answers. Like in ChatGPT, the answer can be like first version or second version, and they can be a bit different or really different. And you are getting a different points of view on the same problem. Because of that, you can probably develop some critical thinking skills also while working with AI systems, AI assistants.
Yeah, I'm developing a Socratic method of teaching with AI, so that the AI is constantly asking questions of the person using it, and the person has to think about the answers, and then the AI will evaluate the answers. But right now, if I try to use that through ChatGPT with prompts, ChatGPT will come out and say, well, here's the answer, or here's how you should write the answer. And then so if a student is trying to write an introduction, for example, to an essay, and ChatGPT comes back and says, well, you know, maybe this is how you should write it, and gives a full example. And then the student thinks, okay, well, I'll always just use ChatGPT because apparently I don't know how to do this and ChatGPT does. And so it seems like, yeah, somehow you have to get around ChatGPT just giving you the answer and making it feel like it knows a lot more than you.
Yeah, I totally agree with that. And also the point is that LLMs right now, they are not very strong in solving scientific problems. So starting from some level, they are not good. I mean, if you are like trying to solve some graduate level problems, then probably most of the LLMs will not help you. And you have to think. You have to think, you have to try, experiment, and so on. But for simple questions like, say, undergraduate level problems or even high school problems, of course, all the LLMs are doing extremely, extremely well. And how to fight that, I don't know. But also, I know that in different countries, there are different AI systems that can help the teacher to teach the material to different students. Like I know that there is something like that in China. So in the class, you have like a teacher and also you have an AI assistant, and you can go and write your question and get the answer with explanations, with some reasonings and so on. So this is another way.
Okay, let's go to Abu Bakar. Can you activate your microphone? Let's go to Che. I see, Che, you wrote your question into chat. In what ways has AI been applied across different fields like healthcare, finance, robotics, and what have been the outcomes?
So in general, I think that we have to apply AI everywhere where it's possible. This is nice. So if we have a tool that can be applied somewhere or there, why not to use that? But in healthcare, as an example, yeah, so you have thousands of medical images. And if a doctor is looking on them, then it's a waste of time, in fact, of the professional. If AI is looking on that and say picking some images, say 5 out of 1,000 that are problematic, or AI thinks that they are problematic, then we can give them to the doctors and see if there is a problem on the image or there is not a problem. So we'll save a lot of time of the professional. In other areas like where to use AI, You said finance, yeah?
Yeah, finance was part of the question.
So as an example, I want to apply for a loan, and if say 20 years ago or 30 years ago, someone, my bank manager, was spending a lot of time to understand if they will give me this loan or will not give them. Right now, AI is doing that for a couple of seconds, checking a lot of parameters connected with me, all the history and stuff like that. After that, the decision is made, yes or no. So it's also saving a lot of time of my bank manager. And these are just very, very simple applications of AI, different areas. Say, in robotics, without AI, robots can do can solve very small problems. With AI, they can do almost everything. And under AI, I mean computer vision, then some speech recognition systems and so on, LiDARs, information from LiDARs and so on, all in one robot.
Okay, thank you, Che. Let's go to Columbus. Columbus, can you activate your microphone to ask your question?
Hope I'm audible enough to be heard. Can you
Okay.
hear me?
We can hear you.
Yeah, I'm asking, where do we classify Gemini? Is it in LLM or is it in a the super AI?
No, it's an LLM. It's a very nice large language model.
And I have seen too much of the lectures that are being done on AI are done from people from I'm sorry to talk about, like, people from Asia and the Pacific. Is it an invention that started in the Asian continent, or it's been from everywhere, like?
I
Because
think
many
that
of the lectures,
your microphone has some problem, and I cannot like hear it's clearly. What's the question?
I am a student of AI at Johns Hopkins. Yeah, so I'm asking, is it because many of the lecturers who are teaching AI, both of them are many of them are from India. They have an Indian. Is there any correlation with them and the discovery of AI, or it's just by coincidence that they teach it? And is there any correlation with them, or it is by coincidence that they teach AI?